There we go. All right. So 2.5 is rational functions and equations. So what we want to be able to do is find asymptotes for rational functions, which we've already done a little bit of, especially when we were talking about domain and range. But we want to be able to calculate a horizontal asymptote, a vertical asymptote, and an oblique asymptote just from the equation itself. You'll also be able to graph them, but we're going to focus a little bit more on rational functions right now. And then rational equations, we want to be able to solve those as well. It's going to involve finding a common denominator. You might find this familiar from advanced algebra trig, or you might not. So here we go, 2.5 rational functions. Where's the top? There it is. 2.5 rational functions and equations. And this pen is dying. Okay, so first of all, a rational function is any function that can be written in this format here. F of x equals a of x over b of x. So a function on the top and a function on the bottom, pretty much. Okay, so if that's a rational function, an example of a rational function would be something like this. That's one example of a rational function. So we have something involving x on the top, something involving x on the bottom. And so what we want to be able to do is take something like this and calculate the asymptotes. Okay, so here we go. So there's three different types of asymptotes we're going to be calculating. The first one is the vertical asymptote, and it's probably the easiest one to find. What if x is an irrational number? X can, oh, like what if the top is something irrational? Like we have the square root of 2x minus 2 or something like that, or minus root 2. It still works out to be considered a rational function. Yeah, it's an interesting idea though. Anyway, so vertical asymptote. The vertical asymptote, all you have to do to find that is take the denominator and set it equal to 0. Take the denominator and set it equal to 0. So for example, in this one, if I take my denominator and set it equal to 0, if we had, the 2x minus 1 over 3x plus 2, I would take 3x plus 2 and set it equal to 0. Subtract 2 from both sides, we get 3x equals negative 2. Divide by 3, we get x equals negative 2/3. So that would be considered our vertical asymptote. That would be the equation of our vertical asymptote. And then if we wanted to see how this would look on the graph, we can plot this. We get 2x minus 1 over 3x plus 2. And if I plot the line x equals negative 2/3, we can see that this is the asymptote. So we did it correctly there. So that would be the vertical asymptote for that. Yeah, and you can always kind of check your asymptote, or like, make sure that it's a reasonable assumption that this is the asymptote by plotting the asymptote and plotting the function and seeing, what it looks like. Does it look like it's actually approaching that value as an asymptote? Because if I solved it wrong and accidentally got, positive 2/3 or something and I plotted it, you can clearly see that this is not an asymptote for the function. So you might want to go back and check. So it's an easy way to check yourself by graphing. So we would have over here negative 2/3. And our function ended up looking something like this with an asymptote here. Okay, so that's a vertical asymptote. Take the denominator, set it equal to 0. That's probably the easier of the asymptotes to find. The one that people tend to have a harder time with is finding a horizontal asymptote, because there's a couple different possibilities depending on how the function's written. So for horizontal, first for horizontal, we have to suppose a few things. So suppose we have this function f of x equals a of x over b of x, this rational function. We're going to say that n is the degree of a of x, which is the top, and m is the degree of b of x, which is the bottom. And remember, the degree is the highest power of x. So we have kind of three cases here. The first case, if n is less than m. So if the degree of the top is less than the degree of the bottom. So what that tells me is that the bottom is going to 0 faster than the top is going to 0 as x approaches 0. And your horizontal asymptote is going to end up being y equals 0, or the x-axis. So for example, if we look at the equation or the function x plus 2 over x to the 5th minus 1, we will see that there is a horizontal asymptote at y equals 0. So let's take a look at that. And that was supposed to be a plus 2. Okay. Well, we can see here that there's going to be an asymptote here at the x-axis at y equals 0. See, it gets very close to 0, but it never actually gets there. Okay. So that's what happens when the degree of the top is greater than, or is less than the degree of the bottom. The second case is if the degree of the top and the bottom are the same. If the degree of the top and the bottom are the same, okay, then the horizontal asymptote is y equals c, where c is the ratio of the coefficients of the highest power of x. From the top and the bottom. So this one's best explained with an example. So here we'll see, let's have 2x minus 1 on top and 4x plus 2 on the bottom. So the coefficients that we're going to be looking at are those on the highest power of x, which is just 1 on the top and bottom. So these two coefficients, if we put them in ratio, c is going to be 2 over 4, which is 1/2. So our horizontal asymptote is y equals 1/2. Y equals 1/2. And we can graph this and see where that happens. So we would have on top 2x minus 1, and on the bottom 4x plus 2. Oops, that didn't erase the way that I had hoped it would. Okay, why does my function look so weird? All right, and then if I plot y equals 1/2, we can see that this is the correct asymptote for this function. Okay. So far we've covered the cases where n is less than m, where n is equal to m, and now we'll cover the case where n is greater than m. So if the degree of the top is greater than the degree of the bottom. And this is the easy case because there is no horizontal asymptote. So we don't have to calculate anything there. No horizontal asymptote. So for example, if we saw something like x cubed plus 2 over 5x minus 1. So let's take a look at that. Okay, so here we don't see a horizontal asymptote. We see something that looks really weird, but there's no horizontal asymptote. Okay, so those are all the cases for horizontal asymptotes, how we would find each one. The last kind of asymptote that we're going to find is something called an oblique asymptote, and that's where your asymptote is diagonal. Okay, so for an oblique asymptote to occur, the degree of the top has to be equal to the degree of the bottom plus 1. So for example, if the degree of the top is 3 and the degree of the bottom is 2, the degree of the top is 5 and the degree of the bottom is 4. So what you want to do to find your oblique asymptote is, this pen is dying too, divide the top by the bottom. Divide the numerator by the denominator. You can use synthetic division or long division. Whichever one you like better. And then what you get, the quotient, is your asymptote equation. It's the quotient without the remainder. That will be the equation of the asymptote. So for example, if we have x squared plus 1 over x minus 2, this will be a case where we have an oblique asymptote because the degree of the top is 2, the degree of the bottom is 1. So I'm going to divide these using synthetic division. So I would put a 2 in the box. And then I have 1x squared plus 0x plus 1. Don't forget the placeholder for the 0x. And then we drop down the 1. 1 times 2 is 2. Add them. 2 times 2 is 4. 4 plus 1 is 5. So then this would be x plus 2 plus 5 over x minus 2. And this will be my equation of my asymptote. So that'll be my oblique asymptote. So we ditch the remainder and we keep the x plus 2 here for our asymptote. Okay, so let's see what that looks like. We had x squared plus 1 over x minus 2. If I zoom out, we can see where it is. And then if I plot the line y equals x plus 2, we can see that that is an asymptote for this function. Okay. So that's how we would find asymptotes for rational functions. So we have the vertical asymptote, just to review. Going back over our notes real quick. The vertical asymptote, where you take the denominator and set it equal to 0. The horizontal asymptote, where you take the function and figure out what category it fits into. If the degree of the top is less than, equal to, or greater than the degree of the bottom. And then from there, you decide what to do past that. And then the oblique asymptote, which is only if the degree of the top is 1 more than the degree of the bottom. Okay, and so when we're asked to find asymptotes, typically we will be asked to find all the asymptotes of the function. So typically it'll have a vertical and a horizontal, but it could have a vertical and an oblique. And some have more than one asymptote and things like that. So make sure you graph whatever function you're given and asked to find the asymptotes for, so that you can make sure that you find all of the asymptotes that are there. And also so that you can make sure that your answers make sense. So what I would personally do is graph the function and then also graph anything that you think is an asymptote, just to make sure that your answer makes sense. Are there any questions so far? Any numbers we don't know where they came from? Anything like that? Okay. If you do at any point, feel free to unmute yourself and say so, or type in the chat. We are going to move on to solving rational equations. So we've dealt with rational functions. Now we're moving on to rational equations. Okay, and solving rational equations, since we're dealing with basically fractions, is going to involve a lot of finding a common denominator and all that good stuff. So if you love fractions, this is a great section for you. We're going to start off with a simple one. X plus 10 over x equals 7. We're going to solve this. So step 1, find a common denominator. In this case, my common denominator is going to be x, because this is the only thing that has a denominator other than 1. So these are all kind of like, this is x over 1, this is 7 over 1, this is 10 over x. Common denominator in this case is going to be x. Step 2, you have to actually make that a common denominator. So in order to do that, we have currently x over 1 plus 10 over x equals 7 over 1. So to make a common denominator, to make this denominator x, I need to multiply by x on the top and on the bottom. And the same thing here. So then we get x squared over x plus 10 over x equals 7x over x. Okay, so now that we have a common denominator, we can get rid of the get rid of the denominator altogether. So when we get rid of the denominator, it now looks like x squared plus 10 equals 7x. And then we want to solve this. So I would subtract 7x from both sides and get x squared minus 7x plus 10 equals 0. And then I would factor that thing. Or stick it into Desmos and click on the zeros if you need to factor it in that way. But things that multiply to 10 and add to negative 7, that would be x minus 5 and x minus 2. So that would tell me that my solutions are x equals 5 and x equals 2. Okay. And then you would want to go back and check and make sure we don't have like a dividing by 0 problem back here, since this was a rational function. If my solution was x equals 0, that wouldn't actually be a solution because x can't be 0 here. But since we have x equals 5 and x equals 2, I can plug in 5 and 2 and we're good to go. And they both work in my function, or in my equation. Okay, so that is one example of a rational equation. Let's do another. Give everyone a moment to finish writing there. Okay. So our next one, so that's example number 1, rational equation example number 2. All right, we're going to have x plus 1 over 3 times x minus 2 over here equals 5x over 6 plus 1 over x minus 2. Okay, so step 1, common denominator. So looking at this, what do we think our common denominator is going to be? Anyone have any ideas? Common denominator. Well, you know it's probably going to have an x minus 2 in it, right? Nice, Carson. You are correct. It's going to have that x minus 2 in it, and I'm going to leave the 3 on the outside, though, just for now. Or, sorry, just kidding. We're close there. It is going to be involve 3 times x minus 2, but it's going to actually end up being 6 times x minus 2, and here's why. 3 goes into 6, but 6 doesn't go into 3. Or at least not nicely. So the nicest common denominator that we can have for this right now is 6 times x minus 2, because I can multiply this by something to get it to be this. I can multiply this by something to get it to be this, and I can multiply this by something to get it to be this. And that'll work out fairly nicely. So 6 times x minus 2 will be our common denominator. And so now what we need to do is go through each of these and figure out what do I need to multiply them by in order to make that common denominator happen. So for this one, I would need to multiply this denominator by 2. Yeah, I guess, and also to address that previous one, you could make 3 times x minus 2. Then you would end up having to divide the top and the bottom here by 2, which would make this a 2.5x, which just gets a little bit messy. So yeah, that's why we're going to stick with this one. But yeah, so this one you'd have to multiply the top and the bottom by 2 to make this into a 6 times x minus 2. So we'd have 2 over 2 times that x plus 1 over 3 times x minus 2. And I would make sure to put this in parentheses so that I remember to distribute the 2 and not just multiply it by the x. And then this one, the 6, needs the x minus 2. So I'd be multiplying on the top and the bottom by x minus 2. And then this one just needs the 6. So we'd be multiplying 6 over 6 times 1 over x minus 2. So now I'm going to go through and distribute. We get 2x plus 2 over 6 times x minus 2. Here I'm distributing this, so we get 5x times 5 is 5x squared minus 10x over 6 times x minus 2. And then we get 6 over 6 times x minus 2. Okay. So now we have our common denominator. All of our denominators should be 6 times x minus 2. So now we can get rid of those. And in step 3, we can deal with the whole 2x plus 2 equals 5x squared minus 10x plus 6. And solve this. So I'm going to subtract 2x from both sides and subtract 2 from both sides to get 0 equals 5x squared minus 12x plus 4. Then we want to factor this. So I'm going to take the 5 and the 4 and multiply them to get 20. Or again, you could just graph this and figure out what the zeros are. But I'm going to have us practice our factoring here. So looking for things that multiply to 20 and add to negative 12. That'd be negative 10 and negative 2. So we rewrite this as 5x squared minus 10x minus 2x plus 4. Then we split it down the middle. Factor out the greatest common factor here, so we get 5x times x minus 2, and then minus 2 times x minus 2. Remember, we want these two things to be the same. That's why you factor out a negative 2 there. So we get 5x minus 2 times x minus 2. And then we want to set these each individually equal to 0. So 5x minus 2 equals 0, and x minus 2 equals 0. To get x equals 2/5 and x equals 2. Okay. So we've solved it, we've factored it. We have two solutions. Will both of these solutions work? What do we think? We look back up at our equation here, our original equation. Does x equals 2/5 and x equals 2 work? No. Why not? Which one doesn't work? Yeah, x equals 2 will not work because notice if I plug in a 2 here, we end up with 0 in the denominator, and that's a problem. So x equals 2/5 is our only solution. X equals 2 doesn't work. Okay. Any questions from that one? Any numbers we're not sure where they came from? Steps we're not sure how they happened? Okay. I'm gonna have you guys try one. Sure, it's not the one we already did. No, we're good. Okay. We're going to do x plus 6 over x minus 8 equals 0. Okay. So go ahead and try that one. Find your common denominator. Make that common denominator happen. And then solve. Notice there's a hint over there as well. It does not factor nicely at the end, so use the quadratic formula. And when you're done, type done in the chat. Do you need that much of it or more, Merrick? Okay. You chose x minus 8 for your common denominator. You're on the right track. You're looking to check your work. I'm starting to work through it up here. Okay. So for this one, here's how I did it. We chose the common denominator of x minus 8, since that's the only thing with a denominator anyway. Then I multiply by x minus 8 on the top and the bottom for x over 1. Multiply it by 0, but anything times 0 is 0 anyway. So we get rid of our denominator and we get x squared minus 8x plus 6 equals 0, but that does not factor nicely. So then we use the quadratic formula, where negative 8 is b, 6 is c, and a is 1. So when you simplify that, we do end up with 8 plus or minus the square root of 40 over 2. But this does simplify further because root 40 simplifies to 2 root 10. So you can fully simplify it into 4 plus or minus root 10, or you can leave it this way. I would not dock points for leaving your root unsimplified. So any of these three things is an acceptable answer to me. Okay. Any questions with that one? Okay. Let's see. So question here, do we want to try one more or do we want to get the assignment? Anyone have an opinion there? All right, let's do another one. Let's see if I can find a good one. Oh, I kind of like that one. All right. We'll do negative 12 over x squared plus 6x equals 2 over x plus 6 plus x minus 2 over x. Okay. What's our common denominator going to be? Here's a hint for this one. I would factor this side first on the bottom to get x times x plus 6. What do we think our common denominator will be here? Yeah, that's exactly it, Jasmine. X times x plus 6, because it combines all three of these denominators here. We've got this one has an x, this one has an x plus 6, and this one has both of those things. So we need both of those things to be part of our common denominator. So our common denominator is x times x plus 6. Okay, so here's the question. Does this one need anything in order to have our common denominator, or does it already have it? Already has it, right? This one is x times x plus 6 on the bottom. So we're good to go for this part of the equation. We can leave this as negative 12 over x times x plus 6. But these two each need something. This one needs an x, this one needs an x plus 6. So to make that happen, I have to multiply this one by an x on the top and on the bottom. And then this one needs an x plus 6, so I have to multiply by x plus 6 on the top and on the bottom. So whatever it needs in the denominator is what you have to multiply by on the top and on the bottom. So let's do that. We've got negative 12 over here, and now really we could get rid of the denominator. We just need this to be our 2x. And then this, we have to actually double distribute everything. So we get x squared minus 2x plus 6x minus 12. And then we got to do some combining of like terms. So we have a 2x and a negative 2x. Those actually cancel each other out. So we have x squared plus 6x minus 12 over here. And then we add 12 to both sides to get it equal to 0. And here I can factor this really easily because it has a greatest common factor. It is just x times x plus 6. So then I have to set this equal to 0 individually. So we get x equals 0 and x plus 6 equals 0, which tells me my solutions would be negative 6 and 0. But then we do have to be careful to go back to the beginning of our equation. Will either of those things, 0 or negative 6, be the answer? Will either of those be able to be plugged in? Well, if I plug in a 0, that's a problem. Yeah, because that's a divide by 0. If I plug in negative 6, that's a problem because that's a divide by 0. So no, neither of these will be answers or will work as solutions to our equation. So this one actually has no solution. These would be solutions if this wasn't the denominator here, or if it was just this that we were solving. But since we have this original equation to look at, neither of those will work. Okay. So at this point, I have posted the homework assignment, but I will stay here and do as many more examples as people would like to stay for. So the homework assignment is a worksheet, and it is posted in Google Classroom. It has finding asymptotes. It has solving rational equations. If you feel good about this and ready to go and work on the assignment, go for it. If you would like to stick around and see a couple more examples, feel free to stick around. I will do as many examples as people would like.